It was once widely believed that optical fiber transmissions were inherently secure. However, we now know that it is relatively easy to tap information out of an optical fiber with virtually no interference to the optical signal. Handheld coupling devices, originally designed as testing tools, are commercially available and can easily be employed by those wishing to engage in information theft. This is why Fiber Census of Oregon has developed SecurLan. SecurLan is a physical intrusion detection sensor for military SIPRNet classified networks or for private sector IT LAN and MAN networks. SecurLan fiber optic sensors enable physical protection with 100% compliance with NSTISSI 7003 and its corresponding guidelines. SecurLan has been tested and approved by the U.S. Air Force Certified Tempest Technical Authority, approved for Priority Level 1 military installations, and has been deployed by the U.S. Air Force at Langley, Scott, Vandenberg, and all of the Pacific Rim Air Force bases, and many others. Recently, the Department of Homeland Security has also deployed SecurLan at their headquarters. In addition, several large military contractors, including Lockheed Martin, Boeing, and General Dynamics, also utilize SecurLan for protecting their data systems. SecurLan has been designed to protect in two ways. First, it provides a security alarm to detect an intentional physical intrusion or the tapping of information from an optical fiber. Second, it provides a way to monitor the physical integrity of the network. For example, when someone is performing routine maintenance of the cable infrastructure, or when someone starts to dig nearby a buried cable. SecurLan determines if a threat is cyber or physical, and thereby accelerates the identification and investigation of the network problem. Let's show how this can be done. The signal starts with the camera attached to a video transmitter, which is connected to a fiber optic cable. The cable leads to an optical receiver, which is then connected to a display. We'll call this TV number 1. To tap the signal, we have chosen to use a commercially available coupling device. The device acts as a tap and is designed to create a small microbend in the fiber, allowing a small amount of light to bleed off. Connected to the yellow cable is a second video receiver, which powers the signal to a second display. When our technician applies the tap, the microbend in the fiber is created and the signal bleeds off. As a result, we now have the same video signal from the camera on TV 2. The images on the TV look identical and are exactly the same in quality and content with minimal dB loss. With this method, an intruder with credentials and access privileges can enter a secured area and with a minimum of effort perform sabotage or espionage by stealing the signal. If the signal were to be data only, the intruder could just as easily download the hijacked data into his laptop computer. So what does this mean to the IT security manager? In addition to the video components, on the table you will notice an APU. This is a Fiber Census FD208 alarm processor unit, connected in a loopback scenario to sensing cable and installed next to the fiber optic cable used in the previous tapping demo. There is an output and an input located on the APU. Also connected to the APU is a laptop computer. Through an RS-232 connection, we are displaying calibration software that monitors the loopback optical signal in real time. The calibration software is called SpectraView. The Fiber Census APU shoots a 1310 nanometer laser through the fiber optic cable and receives the signal at the other end. There is no data traveling through the SecurLan alarm fiber, and the APU is actively monitoring the light signal. Any movement, vibration, or pressure affects the laser's path and is monitored by the system. In the example of metal conduit, this can be the result of a disturbance such as the use of a hacksaw, a hammer, a drill, and also the act of removing fittings. The SecurLan cable is affected and generates an alarm. Here, through SpectraView, you can see SecurLan reacting to movement. Yellow is an event, and red indicates an alarm. And all of this is configurable through SpectraView. SecurLan provides over 30 configurable parameters for calibration via SpectraView, successfully dealing with the issue of nuisance alarms. With false positives eliminated, actual intrusions gain quick attention, and the person attempting to tap is apprehended. To date, the IT and information assurance community has been missing a critical component of the IT security landscape. Our many partners and our satisfied customers agree that SecurLan by FiberSensis fills that gap.